Among the B vitamins, B6 holds an underappreciated position in both neurochemistry and cellular housekeeping. Most people understand B6 in vague terms. It is involved in brain function, it comes from chicken and bananas, and it is one of the nutrients that appears across various supplement labels without much explanation of why it matters. What the more recent research reveals is a connection between B6 status, neurotransmitter synthesis, and the autophagy machinery in brain cells that helps explain why B6 deficiency has consequences for cognitive function that extend well beyond what simple neurotransmitter depletion alone would predict. Pyridoxal 5-phosphate, the active coenzyme form of B6, is directly required for synthesizing GABA, the brain's primary inhibitory neurotransmitter, and for the conversion of tryptophan into serotonin, as well as for dopamine biosynthesis. These neurotransmitters are not merely mood-regulating chemicals. Research indicates that GABA and dopamine signaling directly influences autophagy activity in neurons. GABA receptors modulate the cellular stress responses that trigger autophagy, and dopaminergic signaling interacts with mTOR, the central nutrient sensing complex that suppresses autophagy when active. In other words, B6 affects neuronal autophagy not just indirectly through cellular energy chemistry, but through the very neurotransmitter pathways it is responsible for constructing. B6 also plays a foundational role in amino acid metabolism, and this matters for autophagy in a structural rather than signaling sense. Autophagy proteins, including LC3 and Beclin-1, the workhorses of the autophagosome formation process, are proteins themselves, requiring a continuous supply of amino acids in correct metabolic forms. B6 dependent transamination reactions manage the interconversion of amino acids that cells depend on for protein synthesis. When B6 is insufficient, these metabolic operations become less efficient, and the cellular machinery of autophagy may be compromised not because the signal is absent, but because the building materials for maintaining that machinery are inadequately supplied. Food sources of B6 worth prioritizing include chickpeas at 1.1 milligrams per cup, one of the most concentrated plant-based sources, alongside salmon and chicken breast at around 0.9 milligrams per serving, and bananas at 0.4 milligrams each. The optimal daily intake ranges from 1.3 milligrams for younger adults to 2.0 milligrams for adults over 50, where conversion of dietary B6 to the active P5P form declines with age. For older adults, pyridoxal 5-phosphate supplements bypass the conversion step that becomes less efficient with aging and represent a more reliable way to ensure neurological B6 adequacy. The toxicity warning for B6 is one of the more important in nutritional supplementation and deserves clear statement: chronic supplementation above 100 milligrams daily, a level found in many B-complex supplements marketed for energy and stress, has produced peripheral neuropathy in documented cases, causing numbness, tingling, and sensory dysfunction in the extremities that can persist for months or years after supplementation is discontinued. The therapeutic range studied for specific conditions uses doses in the 25 to 50 milligram range for short periods. Long-term high-dose B6 supplementation without medical supervision is a genuine neurological risk, not a theoretical concern.